Wood pieces in the following shapes and sizes are nailed together in order to create a sign in the shape of an arrow. The pieces are nailed together so that the rectangular piece overlaps with the triangular piece by 4 inches. So this is important information. What is the area of the region in the shape of the arrow? So that important information that I just underlined lets us know that since there's a piece overlapping, we can't count it twice because we in fact have two figures, and this part here overlaps by 4 inches. So we're going to have to make sure that we only count it once and not twice, because as you can see, you've got the area of the rectangle to account for, and we're going to count that overlapping area once, and then you also have the area of the triangle, which we're going to take away that portion of the area. So I know that the area formula of a triangle is equal to 1/2 base times height, so that's 13 times 16, and we take 1/2 of that, so our area is 104. Then we're going to find the area of the rectangle, which we know to be length times width, so that's, as you notice here, it's not in terms of inches like all the other dimensions, it's in terms of feet. So on a Regents exam, you better make sure that all the dimensions are correct. So 2 feet, 1 foot, let me write this down, is equal to 12 inches. And I believe unit measurements, the conversions, are given to you on a Regents exam, so you could always look that up. And since we have a total of 2 feet, that's double the amount of 12 inches, so we get 24 inches. See, it looked very funny to me at first because if you look at the length, that's always greater than the width. Okay, and 2 is definitely not greater than 6, but in terms of feet, it sure is. So 24 inches is my new dimension. So that's going to be 24 times 6, which gives me a product of 144. And then the area of the overlapping piece, and as you can see, that's in the shape of a rectangle, as we were told so in the beginning here. So we know that this length here is the same as this length over here. Maybe I'll highlight this in blue. Okay, these two lengths are the same. Opposite sides are congruent in a rectangle, so this is a value of 6, and we're told that here we have 4. Okay, and it's just length times width in a rectangle, so 6 times 4 is 24. Okay, so it's 104 plus 144 minus 24 is going to be the area of this arrow. And as a result, we get 224 square inches. So we have two squares with side length 5 meet at a vertex, and together with AB, or line segment AB, form a triangle with base 6, as you can see in the diagram. Find the area of the shaded region. So I already know that I'm going to be finding the areas of the two squares and the triangle, and we're going to use their sums as the total area of the whole entire figure. Okay, so I know that the area of a square is side square, and all the sides of a square are congruent, so I have two congruent squares here. So side square is equal to 25, but I have to account for two congruent squares, so that's 2 times 25, which gives me a product of 50. And I'm going to find the area of the triangle, which I know is 1/2 base times the height. However, I have the base, I do not have the height, so we're going to drop a perpendicular extending from this vertex to the opposite side. Okay, so that divides the opposite side into two congruent parts. So a sum of 6 divided in half is going to give me one part of this triangle as 3. And I already know that the length of this side, which is also the side of the square, is 5. So I know that a 3, 4, 5 is a Pythagorean triple. So automatically I know that the length of this side is 4. But if you're not sure, you have the length of one leg and you have the hypotenuse. So all you have to do is plug it into Pythagorean's theorem and find the third missing side. So the area of the triangle is equal to the base of 6 times the height of 4 divided in half. So 24 divided in half is equal to 12. So 50 plus 12 is equal to 62 is the area of the shaded region.